In the first one, x plus 2 times x plus 4. If we FOIL that out, we get x times x is x squared plus 4x plus 6x plus 8. If you add the middle two terms, you end up with this, x squared plus 6x plus 8. Okay? If I multiply out the next one, x plus 3 times x plus 3, what do we get? Go. Please. Because we all know how to FOIL, right? X squared plus 6x plus 9. Is that what people got? All right. Let's do the next one. X plus 1 times x plus 7. Go, please. We get that. X squared plus 8x plus 7. Has anybody seen a pattern here? The two middle ones go together. So these ones, that's the pattern. It's not quite the pattern, but that's okay. But you're on the right track. So the two middle ones do. First one's always x squared. Okay. Let's do the next one. X plus 5 times x plus 2. What am I going to get? You just did that in your head? You know the pattern, you just can't tell me what the pattern is. X squared plus 7x plus 10. People getting these? This is very important. Okay. Do you want to try and tell me the pattern? Do you think you can? Look at this one. That is the pattern, people. Yeah. So if you look at all of these, this n number here is just these two numbers multiplied together. 5 times 2 is 10. And the middle number is these two numbers added together. Look at this one. 8 and 6. 4 times 2 is 8. 4 plus 2 is 6. So what does x minus 5 times x minus 2 turn into? What's negative 5 times negative 2? 10. Positive 10. What's negative 5 plus negative 2? Negative 7x. Okay? So when you are factoring a trinomial, what you're looking for, and I'll summarize this on another page, you don't have to write it down now, is you're always looking for numbers that multiply to the end and add to the middle. Okay? May I flip the page? All right. So before we actually start factoring, we're going to kind of practice this because it's not totally intuitive. You do it in your head. I mean, you can use a calculator, but when you get good at it, you will do it in your head, okay? So if I ask, when I say sum, that means you're adding, and product means multiply. So if I asked you to two numbers that add to 12 and multiply to 20, 2 and 10. Okay, that's what we're doing here. So I need two numbers that add to 9 and multiply to 20. Wow, that was quick. 4 and 5. All right. Another two numbers that add to 2 or add to, yeah, I just told you. Add to 4 and multiply to 4. 2 and 2. It gets tricky when you have negatives. So two numbers that add to negative 9 and multiply to positive 18. Negative 6 and negative 3. Okay, if you're struggling with it, this is what you can do. When I say the multiple, just go, okay, what multiplies the 18? Just give me any of them. So the first two that come up would be 18 and 1. Is there any way I can combine 1 and 18 to get negative 9? No. So then you go, what else multiplies the 18? 2 and 9 is 18. Is there any way I can combine those to get negative 9? No. 3 and 6 multiply to 18. Can I combine those to get negative 9? Only if they're both negative, right? So you just make them both negative. Okay, so that's all. If you're struggling to do it in your head, just take the product and just go what multiplies to that number and see if you can combine them to give you this number. Okay, so let's go over here. We got to multiply to 14 and add to negative 15. So if you're doing the table, what is the first two things that come to your mind when they multiply to 14? 2, 7, and 2. Okay. Is there any way I can combine those to add to negative 15? What about 1 and 14? How would I make them add to negative 15? Negative, negative. Okay. So if you're struggling to do it in your head, do this little factor. It's not a factor tree. You're just figuring out the multiples of it, I guess. What sums to negative 1 or adds to negative 1 and multiplies to negative 6? So let's go here. 6. All right. What multiplies to 6? 1 and 6. Can I combine those to get negative 1? No. 2 and 3. Can I combine those to get to negative 1? How? Which is negative? If the 3 is negative, 2 plus negative 3 gives you negative 1. And 2 times negative 3 gives you negative 6. Okay? So it would be 2 and negative 3. What about multiply to negative 15 and add to 2? Negative 3 and positive 5. And final one, multiply to 48 and add to negative 26. And silence. Let's do the multiples. 48. Sorry, say that again. Negative 24 and negative 2. There you go. The bigger numbers are a little tougher because they have more factors, but as you get good at this, you'll be able to do it in your head. Okay. All I want you to do is number 4, please. It's just practicing that, right? Here we go. So when you get a trinomial and it says factor, so 3 terms, what you're trying to do is make brackets. Okay? And then you ask yourself, the first term, if your trinomial starts with an x squared, the first term in each bracket has to be an x. Because when you FOIL it, you go x times x, which is x squared. So you know that's the very first term. And then you have to figure out what goes at the end. What goes at the end are the numbers that multiply to the end, and add to the middle. So what multiplies to 12 and adds to 8? 6 and 2, both positive. So you write plus 2 plus 6. That is factored. You're done. That's it. That's all you're doing. Okay, and it doesn't matter if you write x plus 6 times x plus 2. The order doesn't matter of the brackets. Okay? Because if I'm going 2 times 3, that is the same as 3 times 2. It doesn't matter when you multiply what order you go in. Okay? So that's all we're doing here. So here's another trinomial. We start with an x squared, so I put an x there. What multiplies to 12 and adds 13? 12 and 1. You're done. X. What multiplies to 12 and adds to negative 13? Silent. Negative 1, negative 12. If it starts with an a squared, what's at the beginning of each bracket? See? What multiplies to 10 and adds to negative 11? Negative 1, negative 10. Skip E for a sec. Go to F. Multiplies to 50 and adds to 27. What? Oh. When you're doing this x disappears because, like the middle term x, because if I go x times negative 12, I get negative 12x, right? And then negative 1 times x is negative x. So when you add those together, you get the negative 13. All right, so just the first term has these. Okay. Sorry, what multiplies to 50 and adds to 27? 25 and 2. Is that okay? Yes? All right. E. What multiplies to 4 and adds to 3? 3 times 1 is not 4. Don't. Everybody does that. Everybody does that in this question. What multiplies to 4 and adds to 3? 4 and minus 1. If you multiply those together, you get negative 4. That would add to negative 5. You can't factor it. It's not possible. It is not possible to factor it. ... in grade 10. Grade 11, you'll learn how to do that. But for right now, we just say it's not possible. Okay? So for this year, unless you're taking Math 11 next semester, you just say not possible. Then you'll learn how to do it. But right now, you don't have to worry about it. On my test, you can just write not possible. Grade 11, there's a way to do it. But right now, there isn't. It's a formula, and it's got decimals and fractions and all that kind of stuff. I can show you later if you want. Not this year, no. I teach Math 12. All right. I need you to do 5, 6, and 7. Before you do that, though, every trinomial that we've done so far, if you look at the first term, what number is in front of the x squared there? A 1, right? Every 1 has a 1 in front of it. even the one that wasn't possible. Okay? What about this guy? It's got a 4, it doesn't have a 1. So when you get a question like this, your very first step is to do what we did on Friday and take out the common factor, the greatest common factor, because you do not want a number in front of the x squared. In Math 10, we don't do anything where the number isn't a 1 in front of the x squared. So I want to factor it out. What goes into 4, 32, and 48? The largest number that goes into all of them. 4. 2 would work, but if you don't write this down, if you do a 2, whoa. If you do a 2, you're going to get this. You're going to get that. What's the problem with that? You still have a 2 in front of the x squared. I want a 1 in there, okay? So we will factor out a 4. If I factor out a 4, what do I get? X squared minus what? The number that you take out, you divide all the numbers. So I'm going to get an 8x. What's 48 divided by 4? 12. So I get a 12. Okay? That's your first step. Now we have a 1 in front of there. So now it matches all the other ones. And now you can use your what multiplies to this number and adds to that number. So I'm looking for numbers that multiply to 12 and add to negative 8. What are they? Negative 6 and negative 2. The negatives matter. Okay? So you get x minus 6, x minus 2. What do I have to remember? The 4. Because if I multiply this out, I should get that back. Okay? So you can kind of just pull the 4 out, forget about it for a bit, factor the brackets to create new brackets, 2 separate brackets, but always remember to write the 4 or whatever number it is beside it at the end. Okay? How is this one different? It has a 3, and there's no constant term, or there's a cube. Everything else that we've done is like squared, and then degree 1, and then a constant term. So, looking at this, what's your greatest common factor? Look at the numbers first. 3, 21, 30. What's common? X squared, or x cubed, x squared, x. What do you take out? An x. What is left inside? What's 3x cubed divided by 3x? X squared. 21 divided by 3 is? X squared over x is x. 30 divided by 3? And what happens to the x's? They're gone. Am I done? No. Because now we go, what multiplies to 10 and adds to 7? 5 and 2. What do I have to remember? The 3x. Okay? So if there's any number in front of the first term, and if the first term is not squared, always factor greatest common factor. That is your first step. Actually, every time you factor, and I will summarize these later on, the very first step is to factor out the greatest common factor. And then use your trinomial factoring, what multiplies to 10 and adds to 7. Any questions about that? It's the same stuff, we just added one more layer to it. We're good? Oh. Why isn't it writing? It's very athletic. Number 10, please. And let's go right into sitting position.